Good afternoon, everyone. I am I was born in New Jersey. I tried to be born in Montclair, but the maternity ward was in Glen Ridge, so technically I was born in Glen Ridge, New Jersey. So it's good to be back in the Garden State. I'm sorry to adjust the schedule, but I have a flight that I have to catch in order to be back in Columbia, South Carolina, my home, for an 8 a.m. Conference that I'm helping to co-sponsor. So I'm very excited to be with you today, and I want to share a few concepts before I get into the meat of my presentation. The essence of what we are trying to accomplish in our company is to try to find creative ways to create multiple uses and multiple purposes for growing biocrops and then converting the resulting biomass into bioproducts, and hopefully doing that multiple times. And I'll discuss some of the approaches that we're taking as I move through my presentation. I believe that the bioeconomy can solve a number of environmental challenges and problems that the world faces. And we need to be thinking, in my opinion, about how many of those challenges can we reasonably accomplish in addition to what we might normally just be expecting for the use of biomass. For example, in our country, we have an interesting situation where, of course, EPA is concerned about emissions from coal-fired plants. That's a reasonable concern. And yet we have millions of acres of forest land in the western part of our country that's either beetle infested or somehow damaged by fire, or poses a threat for a catastrophic or continuance of catastrophic forest fires. And yet the two policies or the two concerns that would seem to be logical to me would be, there is existing technology today that can convert wood material into a bio-coal. And while the economics of doing that may not be as attractive as one might wish, being able to concentrate on that combined activity of finding a solution to the forest fire problem, coupled with the need for more renewable fuel use in our utilities, is something that we could actually begin implementation almost immediately. And I hope that the policymakers will take a look at that opportunity and do something about that. So it's in the spirit of trying to maximize the benefits of the bioeconomy that I'm here with you today. And then the last area that's been a personal interest to me has been, how can we use the bioeconomy to reduce the economic disparity between racial communities in our country? How can we help create jobs in rural communities? How can we give even small landowners, I was intrigued by the presentation on the algae. That looks like an opportunity that relatively small landowners could get involved in, and might be a way of maintaining land ownership and wealth, particularly in the rural African-American community. So today I'm going to talk to you about the multiple benefits of a process that we've developed that combines the remediation of soil and water with the production of biomass, and sequentially the production of bioproducts from that biomass. And we are looking for opportunities, and we have some already, where that seems to make sense. So right now we face challenges. They're global. We have challenges in soil quality and productivity, water quality, and also biomass availability. The billion-ton report is really focusing us on how much biomass is there available for having the type of bioeconomy that we'd like. So there's a need for remediation and stabilization of soils and water that also can increase the availability, and if done properly, possibly reduce the cost of biomass as well. Without going into detail, EPA has a Repowering America's Lands initiative, And according to their statistics, there are about 490,000 contaminated sites across the US, which total almost 15 million acres. So that's 15 million acres, obviously some percentage of that, on which the possibility stands to grow biocrops and use what scientists call the phytoremediation capability of their root systems to extract problematic substances from those sites. We believe that lowering the cost of biomass and therefore the effective cost of bioproducts and biofuels will increase utilization. So we're working with we call them operating affiliates, to sustainably grow, use, and convert plant, wood, and other forms of biomass into a variety of bioproducts. This combined remediation, biomass, and bioproduct production process intentionally uses biomass allotments multiple times as follows. So, for example, challenge sites are cost-effectively treated by planting biocrops in them, and that's true for both land and water sites. And I'm very interested in talking more with the algae expert that just presented, because we have some applications where we might combine the planting of these crops with algae production and potentially growing fish in places where we're trying to improve the quality of water and generate byproducts that make the economics work. We use the roots to extract pollutants, and in some cases to anchor soils in places like Haiti, where trees have been cut down to make charcoal cooking fuel, and topsoil is running away. And there's opportunities to create storm and freshwater solutions using these very same crops. We then harvest them, and in most cases we shred them, and in some cases we can directly use them or immediately use them as they are as bioproducts. And I'll talk a little bit about our work in the Chesapeake Bay watershed, where phosphorus pollution is creating problems and algae bloom in the Chesapeake Bay. And that's because farmers have used poultry litter as part of their fertilizer regime for decades, increasing the amounts of both nitrogen, but particularly phosphorus, in those soils. So one of the alternatives we have there is to plant biocrops, and you'll see in a minute a slide that shows you a comparison of regular sorghum and biomass sorghum. You saw that earlier today. But our sorghum genetics partner believes that between 120 to 250 pounds of phosphorus per acre per growing season can be extracted from those soils. The poultry industry is still very strong because of farming and other development. The availability of wood, in other words, forests, are no longer in the Chesapeake Bay watershed, at least in the Maryland portion in which we're working at the moment. And therefore, the poultry industry has to ship in wood chips or sawdust from the mainland, and that's an expensive proposition to do. So here we create a situation where after harvesting the crops, we can shred them, and it actually turns out, we believe, that they're actually a superior bedding. They have more absorption capability and some other benefits, which we hope to test out in the coming years. Once the chicks have made their contribution, in other words, once they've pooped on the bedding, we collect it and run it through a pyrolysis system that turns it into a phosphorus and otherwise nutrient-rich biochar, rich enough, we think, or valuable enough to afford it being shipped out of a phosphorus-rich or phosphorus-contaminated area to other parts of the country where it can be better used. Some of the other products that we can make include a filler. You know, most plastics are a combination of polymer and some form of filler. We're finding we can make a filler that makes plastics that are stronger, lighter, water and heat resistant, and those fillers may cost less than their fossil-based alternatives. We're very excited about that because certainly the automotive industry is looking to lightweight cars and looking for materials that help them do that. And we have other applications as well for that filler. And then lastly, using again a pyrolysis system, we can make biocoal. We may have to extract the ash creating substances that are in plant-based biomass because they create problems when you burn them. But we can make that from these types of biomass as well. So here again is a picture of standard sorghum and compared to biomass sorghum. Our genetics partner is Chromatin, a company out of Chicago. Some of the ways that we would use our process, obviously we'd like to work on polluted land and water, soil erosion. The strategy again is to reduce both feedstock and bioproduct cost, and we think we can create a cleaner and safer environment, saving a lot of money and creating jobs and profits. The pyrolysis process that we use is called torrefaction. We have licensed the torrefaction technology developed by North Carolina State University. It essentially heats plant and wood material in a low oxygen environment, turns it into a highly carbonaceous material, energy dense, brittle, and with other characteristics that make it appropriate for the products that I've just described to you earlier. Here's a rendering of or schematic of how the torrefaction process works. The green biomass enters the system on the upper left-hand side. It is augured through a series of tubes that are surrounded by a heat chamber. We collect the volatile organic compounds. In other words, we collect the pyrolysis gases, and once we're at operating temperature, we use those to make all process heat. We do not need outside energy to make the heat that's required to make our system work. Here are some products and values of those products that we're working on right now. I mentioned the filler. So it may cost us about $150 a ton with regular feedstock pricing to make torrefied material or the char material that we use. The plastic fillers will sell in the range of $300 to $600 a ton, so there's a good markup there. We've just signed a cooperative research and development agreement with the USDA ARS Western Regional Research Center. They have, like we have, been doing research on the use of such material as fillers, and they, as we do, have customers in hand who have an interest in that product. The next product is biochar. I mentioned that earlier as a product that we can make from poultry litter and other forms of litter. That too is a valuable product, although it's still being understood and determined in the marketplace to what extent it's going to be used. In third world countries that have traditionally chopped down trees and piled them up and set them on fire and then in a very haphazard way made biochar, we can make biochar, as I mentioned, to replace to decrease demand for wood-based charcoal in certain parts of the world. And then lastly, the biocoal. I mentioned that we're currently at work in the Chesapeake Bay watershed. We've demonstrated the ability for the biomass sorghum to grow. We had a small crop last year. We're intending to plant again in this coming year. And we're working with the USDA Natural Resources Conservation Service to qualify the planting of these crops as a best management practice. And why are we doing that? Because that will help to generate conservation payments to landowners who grow such crops in such a manner and help to increase the viability of the entire process. In South Carolina, we're looking at coal ash deposits. We're looking at wastewater treatment plant spray fields. You may or may not know that particularly in rural communities where there's plenty of land, a wastewater utility will clean water to a certain point and then spray what I would call gray water into grass or hay fields and let those fields and the roots of those crops do the finishing. Unfortunately, many of these systems are in non-compliance because the spray fields simply don't have the capacity to treat as much water as the utility would hope. However, you can imagine the differential in the root size and the capabilities of some of the biocrops I've just described to you. We think they can very substantially enhance the productivity of these spray fields. We're also looking at and have met with, we're looking at the largest lake in California. It's called the Salton Sea. It was formed, it's a mistaken lake, believe it or not. Back in the early 1900s, the Colorado River, which is the eastern boundary of Southern California, was breached. And you may know the San Andreas Fault flows from north to south through California. And in most places, it's the lowest lying land. So for a year or so, the water from the river settled and created a 900 square mile lake. Not very deep in most places, maybe 40, 50 feet deep maximum. Unfortunately, that area was a former seabed, so there was a lot of salt in the soil. There was a lot of selenium in the soil. And also, you may know the valley region of California being a very strong agricultural area. And so all the farm runoff carrying phosphorus and insecticides and other stuff would flow into the lake. The lake is now 1/3 of its original size because of the high rates of evaporation, and the concentration of those nasty things is very high, so high that birds which have used the lake as part of their flyway in migrations north and south are finding it difficult to land there and live there. Fish can no longer live in the lake as well. And unfortunately, the former lake bed, which is now twice as big as the remaining lake, is a dust bowl. And so the nasty stuff, including the insecticides and other things that farmers have used, are now dispersed. And I would guess maybe half or some significant number of the population there are suffering from respiratory disease. So we think we have a 3-medium application opportunity there. We could plant biocrops in the farmland to help extract phosphorus and other things before they hit the water system. We can plant these crops in the former lake bed as well, as a way of both breaking the wind and creating enough shade to increase the levels of moisture in the soil to cut down on dispersion of the dust. And then lastly, creating sort of a floating farm, if you will. We believe that we can suspend our crops over portions of the lake and let their root systems do some cleanup in the water, which we would control in a chamber underneath the flotation device so that the water is not so toxic that it would kill our plants or kill fish or maybe even algae that we might grow in that system as a way of trying to create as much value as possible. So let me close here and thank you for the opportunity to share this concept with you. I think I've already found at least 2 people with which we'll collaborate because of having a chance to chat with them. And I'll be glad to answer any questions you might have right now.